Hi, Honors Trig Pre-Calc. As I mentioned, we're going to do this example as a video. I believe the problem in the homework is either 49 or 59. I don't know. It's something with a 9. And if you want, you can watch this video to get help on that problem. Otherwise, I'm sure you could probably figure out the problem without. So it says a hard-boiled egg at temperature 100 degrees Celsius is placed in 15 degrees Celsius water to cool. 5 minutes later, the temperature of the egg is 55 degrees Celsius. When will the egg be 25 degrees Celsius? So we have to start by identifying the things we know. It says a hard-boiled egg at temperature 100 degrees Celsius. So that's our initial temperature of the egg, T sub 0. T sub 0 is 100 degrees Celsius. And then it is placed in 15 degrees Celsius water to cool. That's the medium it's being placed in. So that would be T sub m, 15 degrees Celsius. It says 5 minutes later, the temperature of the egg is 55 degrees. So after 5 minutes has passed, when lowercase t is 5, capital T is 55. So we could write that as T of 5 is equal to 55 degrees Celsius. And it says, when will the egg, so at what time will the egg be, will T of t be equal to 25 degrees? At what time? So they're looking for what time is this true? All right, so let's start by putting the information we have in, and I'm going to change my pen color, I think. All right, so we're going to plug in all the pieces we know, right? So we have T sub m, 15, plus T sub 0, 100, minus 15, times e to the negative. We don't have k, but we can find k by using this point here. So I'm going to put 5 for t, and then my y value, my T of t, is going to be 55. So right now, I have one variable in this equation, right? K is a variable, E is not, E is a number. So let's solve. 100 minus 15 is going to be 85 e to the negative 5k. I'm just rewriting this exponent, and I'm going to move the 15 to the other side. So this is equal to 40. Divide both sides by 85. We would have 40 over 85. And yes, we could simplify that, but we don't really need to. E to the negative 5k. This is as far as I can go in this form. It's in exponential, so I need to write it as a logarithm. Now remember, our swirl works when the base is on the left, so I can either rewrite this as e to the negative 5k is equal to 40 over 85 and then do a little swirl, which would mean log base e of 40 over 85 is equal to negative 5k, which is perfect and correct. Or I do want to show you one other idea, which is really doing the same thing. But the other way we can think about it is, how do I get rid of a base of e? Well, I would be taking the natural log of this right side. If I take the natural log of the right side, natural log of e to the negative 5k, well, natural log of e, those are going to cancel out. But if I do something to the right side of the equation, I must do it to the left side of the equation as well, right? We got to balance those sides. So natural log of 40 over 85. And so technically we're at the same point on both of these. When I say we're at the same point in both of these, I mean this equation over here is the natural log of 40 over 85 is equal to, not the e, sorry. Natural log of e, remember we don't have that anymore, so it's negative 5k. And over here, log base e, remember, is really natural log of 40 over 85 is equal to negative 5k. All right, so long story short, we get to the same point, right? Both of these two methods are exactly the same. So regardless of which way you do this, with the swirl or taking the natural log of both sides, we are now here. From here, we would solve with our calculators. Type in natural log of 40 divided by 85, get that decimal, then divide it by a -5 to solve for k. If you want to pause the video right now to see if you can get it, do so. Otherwise, k is equal to 0.151. Now, this is not our answer. We just found the value of k, which was a variable. However, we need this to find our answer because we need that value in our equation. So now we have the temperature at time t is equal to 15 plus 85e to the negative 0.151t. This is our general equation. And remember, at the beginning, our goal was to find the time at which the temperature was 25. So we're going to plug in 25 for this y value. 15 plus 85e to the negative 0.151t. And from here, realistically, we're solving in exactly the same way we just did. I would start by moving the 15 over, dividing by the 85, and then changing this exponential to a logarithm. I am not going to show these steps because we just did them. However, if you need help, by all means, let me know. When you solve this, you should get t is about 14, is it minutes? Is it 5 minutes? 14 minutes. If you're not getting 14 minutes, please let me know. I would be so happy to help you figure this out. Otherwise, I hope you have a lovely rest of your day, morning, evening, whatever time you're watching this, and I will talk to you soon.